Okay, for this video we're going to talk about two concepts. We're going to do the concept of writing your own functions, and we're going to use the for loop. So first we'll start out by doing the standard and include the PixelGrid library, initializing PixelGrid.setup, and then in your loop function you clear the screen and update. And we'll put our code in between here. So we're going to use a sine wave. If you haven't ever seen a sine wave, it looks like this. So it's a math function that oscillates between -1 and +1 across 0 to 360 degrees. So you basically plug a number into this function and you'll get out a number between 0 and 1, or -1 and +1, based on where you are. So let's make ourselves a variable. T equals 0. This is going to store where we are on the sine wave, and then this dt variable will be how fast we're going to move along the sine wave. And to calculate where we are, say, make another variable, float y equals sine of t. Now we're going to want to stretch this a little bit vertically so we can see it. So we'll multiply it by an amplitude, and maybe we'll use an amplitude of 4 since our screen is 13 pixels tall. An amplitude of 4 will give you a sine wave that's 8 pixels, since it goes from -1 to +1, and we'll offset the y value to be in the middle of the screen. So hopefully that makes sense. We're basically taking sine of this value t, we're multiplying it by 4 to make it taller, and then we're adding 6.5 to move it down the screen. So basically this is 0 and this is 6.5 should be in the middle here. So now we can use this coordinate we've calculated to draw a pixel. For now, we'll just put the pixel in the center on the x-axis and at the y value, and we'll make up a color. Okay, so the only thing left to do is we want t to change for this demonstration. So each time through the loop we're going to say t equals t plus dt. So loop runs 100 times a second on PixelGrid, and each time it runs we'll add dt. So in 1/10 of a second t will go from 0 to 1, for example. Let's go ahead and build this. Okay, so you can see the point is moving up and down based on where it is in the sine wave. So the first thing I want to show is how to write your own functions. So let's make a function that calculates the sine wave instead of putting the code directly inside loop. So we have float. We'll call it calculate y. It's going to take a parameter of t. This is the format of a function. You say, what's the function going to return? That could be void. It could be an integer. In our case, we're going to be a floating point number because we have fractions. And then you give the function a name. It can be almost anything, but you just can't start it with a number. And then you have an open paren and a closed paren, and you put any number of parentheses. It could be no parameters. I said parentheses, I meant parameters. So if you put void, then you would call that function by saying just like that. But if we want to do t, then we would call it by, say, my variable, some variable. Inside the open and close curly brace, you put the code that's going to execute as part of this function. And we're going to use this code here. So I'll just copy and paste it. So now I have a function. When this calculate y function is called, it'll calculate a local variable y using this formula. And then the last line of the function, we need to say what it returns. Now there's still a little bit of a problem here. I'm using a global variable here. Well, actually, this variable is not defined anywhere. It's a local variable to this code. When you declare a variable, it exists within its set of curly braces. That's called a scope. So we need to pass in that as well. So we'll say pass in float. We'll call it a for the function. So y equals a times sine of t plus 6.5, return y. Now to use it, we will come down here and we say float y equals calculate y t comma a. Well, actually, we've called it amplitude here, so we would call it amplitude. Or we could actually just do this. But for now, we'll leave it at amplitude. Now, if I run this function or this code, it should do pretty much the same thing, or exactly the same thing, as long as we didn't make any mistakes. And it looks like it does. So we can sort of use that, use that function as much as we want. Say y2 equals t plus, instead of amplitude, we'll use 1.5 times. So here I kind of stuck some code in line. This is the same as if you'd said something like this. Float t2 equals t plus 1.0f, and then you put t2 here. But since we don't really need t2 as a separate variable later on in the code, sometimes you just put a little formula right in place. And let's draw y2 now. We'll draw it at 8, y2. And another random color. So let's see what this does. Okay, you can see the green dot is at a different point in time along the sine wave, and it's moved over on X. So if we drew a dot for every pixel on the display, we could see the shape of the curve. So let's see an easy way to do that. So in order to do that, I'm going to introduce a new concept called the for loop. In C++ programming, this is a built-in keyword. So you say for, an open paren and a closed paren, and an open curly and then a closed curly. Oops, I ended up with an extra curly. Now, whatever is within these two curly braces will be executed over and over based on the parameters you put in the for loop. The for loop takes 3 parameters. So first we'll say, let's declare a variable int x. The first one is the initializer of the loop, x equals 0. Second parameter is the condition for which the loop should continue running. So we're going to say x is less than 13. And then the third thing is a piece of code that will execute each time through the loop. So usually it's a increment your counter. So this is a simple way to make a counter that goes from 0 to 12. This is once it is no longer less than 13. So once it equals 13, the code will exit the loop and continue here. Now, let's make ourselves we're going to draw a pixel on each of these x coordinates, and we want to calculate a different y coordinate. So let's make ourselves a temporary variable here called t, and that's going to equal, well, we'll call it t temp. How about that? And we're going to have that start at t, but increment based on where we are on the screen. So we'll say plus x times, ooh, my fingers are off. So this will make it when x is 0, temp will be t. When x is 1, temp will be t plus 0.1. When x is 2, it'll be t plus 0.2. That's just a simple formula to make this temp variable change as we go across the loop. There's lots of other ways you can do it, and there's always a million ways you can do anything in programming. So now we're going to say y temp equals calculate y of, and we want to use this value here, temp, and then the amplitude, we'll go ahead and use the same amplitude. And then we'll draw the pixel. So we can use the x value in the loop because it's going across the screen, and then we can use this value that we calculated for this x and another random color. Let's see if that compiles. Might have made a mistake somewhere. Oh, it looks good. Okay, let's see what this does. So I should still have the two moving dots, and then I'll also have the pink line, which is the sine wave. Now, how fast we were incrementing our temporary t value is how much of the sine wave will show. So this formula here, this number here controls how much we incremented by as we move across the screen. So if we made this like 0.3, we'll see more of the sine wave, and then we can make a. I think I got a. There we go. And then why don't we make our amplitude bigger just to make it more interesting? We'll just use an amplitude of 7 here. Actually, that might be too big. Well, we'll see what happens. Oh, I accidentally deleted a bunch of code here. Let's just undo. Okay, well, I'm going to have to write it again. X, comma, y, temp, comma, I think I used something like 200, 0, 80 or something like that. Okay, let's download this code. So there we have a cool looking sine wave and 2 bouncing dots. Let's take it one step further. So we've made ourselves this function for calculating a point on the sine wave. Why don't we make a function that can draw a whole sine wave, and we can draw a couple of them. So let's say in this case this is going to be a function that just does some work. It doesn't really return anything. And the parameters we're going to take are going to be, let's say we want an amplitude, we want a how fast we're going to change t as we go across the x-axis, so we can call that x scale. Is there anything else that's going on here? That looks good. So it's going to be a function that takes 2 parameters, and you do your open, close curly, and then we just put our code in here. So inside here we'll just go ahead and chop this out. So we've created a local variable, and once again loops across the screen. We've given ourselves a new variable called x scale that controls how fast t should change as we move across x. So we'll just use that variable now. Once again, we're using the calculate y function on the t value and the given amplitude. So we called amplitude a here, so we'll just call it a. And then we draw a pixel. So let's use it. Draw sine wave. First parameter is amplitude. I think we did 7.0 there. And we had let's see, x scale. So we had, I think, 0.3 for that. Actually, let's have it like I didn't define t. Well, right now it's going to use this global t, but instead we would like to be able to draw sine waves when we call the function, have it draw wherever we tell it to start. So we'll call it float t0, and then have this call t0. So we'll draw from t0 across the screen based on x scale. And when we do our draw sine wave, started at t, amplitude of 7, x scale of 0.3. But now, since it's a function, we can do multiple. So let's draw a second one at t plus 0.5, and maybe we can make it a little bit shorter, and we can make it oscillate a little bit different rate. So you see how once you've turned it into a function, you can reuse it. And it kind of takes a little bit of practice to decide how you want to parameterize your functions. What should they always do versus what can you change based on the inputs. Like even as we were just talking, I changed my mind 3 times. And that's fine. That's programming. Let's see what it does. So ideally we should have 2 sine waves and 2 dots. Yeah, there we go. We could also make it so you can control the color of the sine wave. So why don't we, I'll show you how to do that. So the color is a little bit more complicated a subject because it uses a custom type, but for now I'll just show you how to do it. PG color C. So the type of a color is called PG color, all caps, and then the variable name I've created is C, and then I would just use C here. So I'm going to cut this, Control X, and then I'll put C here. And then down here where I call sine wave, I need to add another parameter. So we can just paste it there. But instead of using the same color for both, we can use, oops, 2 different colors. Okay, what's the problem here? PG color has not been defined. Well, I think it's lowercase actually. Sorry about that. I forgot how I defined it. So PG colors, the type for a PG color variable is all lowercase. And then the macro is all uppercase. Yeah, of course. Okay, so let's download that. Okay, so I don't know if you can see on the video. One of them's purple, one of them's pink. Let's make it a little more different. So we'll go like this here. And you can keep going. And let's draw 3 sine waves. Since we've made a function, it's really easy. So, of course, we don't want to draw the same one on top of each other, so let's change some of this stuff. Let's make this one really low. We'll make it move really fast, and we'll start it out at a different place. It's good practice to use, like I had this as 0.5 earlier instead of 0.5f. This defines a double when we're really using floats. It works fine, but just get in the habit of, if you're making a floating point constant, put the f on the end of it. There you go. So let's review. We made some functions. A function has a return value, a name, and a list of parameters. Functions can call other functions, like our draw sine wave function calls the calculate y function. When you call a function, it looks like this, and you pass whatever you want in here. They don't have to be the same letters. You know, this is the name of the parameter within the scope of this function. This is the name of the value you're passing into it. So, you know, it can be variables, it can be numbers, it could be, you know, you can have little formulas here. It's all very flexible what you can do with it. You can call your, you know, now you've got a reusable function, you can call it over and over. And then we talked about the for loop. So in order to make an x value that walks across the screen, and then we did some calculation on each column of the screen, we made this for loop where you initialize the loop, you give the loop condition. So once this goes false, it falls out of the loop, and then you give the loop, like, I forget what this is called, but it's executed once per loop, and normally you just increment your loop counter here. So yeah, you can play around with this code, make interesting looking sine waves.